Very lucky to have Randy Houston with us. He's the Program Delivery Executive of Xcel Energy's Smart Grid City. He's got more than 30 years of experience in electric power, an extensive background in asset management, including GIS, outage management, workforce management, and more. Now, and here's the interesting thing. Smart Grid City incorporates almost all aspects, including supply, transmission, distribution, and managing the data, which is what we're here to talk about today. Because Smart Grid City is literally one of the most significant smart grid projects in the world, Randy's in very high demand. And he's actually at a meeting today of the National Governors Association, and he stepped out to join us. So we're very grateful that he's here. Randy, I'd like very much to zoom through some of these very interesting slides you've got, and then save a few minutes at the end to ask questions. As a reminder to our viewers, you can type questions into your screen. Randy.
Thank you very much. Appreciate it. On this slide, what we're basically illustrating is the fact that the utility environment is changing, and it's changing in ways from top to bottom in terms of storage devices, on-site power, flexible demand response, pricing signals, and so forth. A lot of the conversation so far has talked about the grid side of it, but as Jesse mentioned, one of the things we're very interested in is the impact of this on a company-wide basis. To do that, we decided that we would basically do a complete city, and we took Boulder, Colorado, and decided that we would be looking at new technologies, processes, building skills and experience. We developed a set of 60-plus hypotheses, which we're testing, evaluating the benefits, and basically getting the chance to leverage the best talent through a consortium of partners. And this is just a list of some of the partners. Accenture is one of them. We also worked with people like Current and GridPoint, Ventex, SEL, and so forth. As of today, we started the project in 2008. The bulk of the infrastructure went in by June of last year, and we've been working on getting approvals, which we just received, and we're beginning deployment of field equipment. So very quickly, we've either developed or integrated over 25 apps, 95 interfaces, multiple new security technologies. Well, at this point, the communication is complete. 200 miles of fiber cable were installed, 42,000 premises over broadband. This is 3 of 4. We've since completed all 4 substations, completely redone them so that they are using completely new technology. The 4 feeders have been automated, 23 are being monitored. This includes power quality meters, synchrophasers, and so forth. Over 4,000 transformers are monitored. Over 20,000 meters are installed in 8 pilot installations, and those are about ready to go up. One of the what this slide's illustrating is on the smart meter data. Some of the things that we've already seen, and we've presented to our commissions, are that we've been able to enable the remote meter reading. We're using that both for diagnostics. All of our field technicians can do it, call center personnel. We're using it heavily to identify nested outages. We've seen a dramatic reduction on OKN arrivals because we're now able to effectively go out and find what the problem is or if there is a problem. And as most utilities, we were finding about 40% of our truck rolls on single calls were actually OKN arrival, and that's been reduced virtually to 0, as that is pointing out. And there's the next slide coming up. We've also actually have reduced truck rolls in many different ways by using not only data from sensors, but by overlaying things like satellite mapping so that our trucks can see where equipment's located and they know what to dispatch properly. On transformer monitoring, it's completely changed the way we're doing our planning. We're actually seeing loads. We've set thresholds. We're detecting problems before they happen, and therefore we're taking care of them before they break. So it's really interesting that the system is being run now from everybody talks about preventive maintenance. It's truly being run in a preventive manner now. What this is basically indicating is unpredicted failures, what we're called current look. That's the application we're using, detections, and Boulder's total. And we had been in 2005, 2006, things had been going upwards, as you'll notice. and in terms of outages. We actually, as you'll notice, once we started putting the system in, they started to fall, and so far this year we haven't had any. It's still early in the year, but even last year it was less than half of it, and we didn't have the whole system in all year.
That's quite remarkable right there. Wow.
Yeah, and you'll see this on the next slide because of what it translates to.